All right, so here is a mini lesson on solving simple inequalities. So very, very, very similar to our simple like one-step equations when there was an equal sign. It is going to be basically identical, except with an inequality. So we're just going to pretend that the inequality is an equal sign and just write an inequality at the end instead. So let me show you 4 examples, one for each, and then I'm going to show you kind of like a special case. So if I had 4 plus x is greater than or equal to 6. Just like if that greater than or equal to sign would be like an equal sign, we're going to look at the stuff that's on the left-hand side and say, what do I have to manipulate in order to get x by itself? Well, my 4 is positive, so I'm going to subtract 4 from both sides, and then I have x is greater than or equal to 2. And then that is something where you could either plug in those values kind of like we saw yesterday. You can make a number line, stuff like that. We can use that to compare. All right, same thing happens if I have subtraction. So let's use a different letter. So y minus 3 is less than 4. And again, coming up with these literally off the top of my head. Looking at my inequality sign, we got to figure out what we need to move away from y to get it by itself. In this case, 4 plus 3 would then give me 7. So y is less than 7. All right, now multiplication and division. Undoing those, if I had 4x is less than or equal to 16. Well, I'm going to divide both sides by 4 like typical to get those 4's to cancel. So then I have x is less than or equal to 4. Meaning I can plug anything, 4, 3, 2, 1, or anything in between those, like 4.25, or not 4.25, 3.25, 2.73594. As long as it's less than or equal to 4, it works. All right, and then division is going to happen the exact same way. So, and actually I'm going to have 2 division ones to show you. So if I have 3, x over 3 is less than 9. That's what we'll do first. Okay, very similar to everything else that we have done. Noticing the division, we're going to use the opposite operation to multiply those. So then x is less than 27. Okay, now another variation of that, let me show you, let me change the color actually to green. So if I had those flipped, because that's what I was going to do first, and I was like, maybe I shouldn't. Notice how the letter is on the bottom. I cannot just multiply both sides by 3 because I'm currently not dividing by 3. I'm dividing by x. So I'm going to multiply both sides by x first to get 3 is less than 9x. And then it turns back into a multiplication problem like we have over here, where I'm just going to divide both sides by 9. So 3 divided by 9 simplifies down to 1/3. Whether or not you got that or not is completely fine. But then there we go. Okay, now if you don't like seeing your answer like that, let me switch to maybe blue. Okay, some equivalent ways to write it. If you like having your letter first, notice how over here my inequality sign is facing x, like it's going to eat it, like that alligator comparison that we always kind of hear. As long as it is still trying to eat x, you've rewritten it correctly. Okay, let me get that guy out of there. So both of those are exactly the same. Okay, now the only caveat that we have to deal with is if you multiply or divide by a negative number, the sign flips direction. So here is an example of each. We'll do negative 3x is less than 27. Okay, when I'm here and I need to divide both sides by -3, divide by -3, x, my sign flips direction, and then I actually do that division. And it's because I have 2 negative numbers when we're starting to compare things. That's the only reason that sign changes direction. Again, only if you're multiplying or dividing by a negative. It's not anything with addition or subtraction, because that's its own thing, multiplication and division only. So here's one more example. Let's use, okay, so x divided by negative 2 is greater than or equal to 4. Well, very similar to before, we're going to multiply both sides by negative 2, multiply by negative 2. Notice, multiplying by a negative, we are going to flip that sign to then get negative 8 for our answer. Divided by a negative over here, multiplied by a negative over here, sign flips directions in both cases. Now, if, because this, I remember this from previous years of teaching this, if, for example, that 4 would have been negative and that 2 would have been positive, we're technically still multiplying by a negative, right? Like that would still be kind of what it is. However, the number that we are multiplying both sides by wasn't or wouldn't be negative in that case with my green writing over here. So only if it is the thing that you were multiplying both sides by. If that thing is negative, we're dividing. If that thing on both sides is negative, then you flip the signs. It doesn't matter what this number was doing before we got over there, because that one wasn't attached to our letter. That one's not affecting us as much. Okay. All right, that is our mini lesson on basic inequalities. Again, very similar to when it's an equal sign. But if you're having any troubles, make sure you let me know.